Yeah.
Then C2 and L2. So after adding that value for the equations, you can calculate that bundle number 2, right? So 6.23, isn't it? Yeah, 6.23 for the consumption, 6.23, leisure for the 1.46. Right. Those are the things you have to identify after two bundles. So then you have to utilize that vertical axis and horizontal axis separately. This horizontal axis for the leisure. Okay, leisure.
Yeah.
This vertical axis for the consumption. So then we are going to draw up the IC curve. Then you have to identify this IC curve. It doesn't going to cross out the horizontal axis either vertical axis, because if any IC curve cross the horizontal or vertical axis, that means one part of the commodity becomes zero. So we are
Yeah.
not going to consider something like that one, because both of commodities are going to consume. Because of that, they can maximize their satisfaction. Okay, in here you already identify the utility level is 5.995. This is utility level. Utility level. You calculated that utility level under number 5 question. Okay, the number 5 question. Total utility, by using total utility function, you already calculate the utility. Assuming that C equal to 7.2 and L equal to 0.36. Then the utility level become, in each and every point of the IC curve, the utility level is similar. It's not going to change. And then I'm going to point out this A as bundle number 1. Right? This V point consider as bundle number 2.
2.
When you are going to consume in the first position, consumption 7.2, this one. Right, but then what happened to the L becomes 0.36. So then
Yeah.
if consumer change their preference into V point, consumption reduce 0.23, and B point for the leisure it becomes 0.46. So those are the 2 points you have to consider related to the creating a sketch related to the IC curve. Okay, finally you have to create something like that equation. Okay, right. Let's move to the question number 1. It also similar to the IC curve and consumption, but in third question is different from the question we already discussed in here. Right, because of that, the third question take another knowledge. You need another knowledge to describe that. Okay, right. Okay, this one. Question number 2. Yeah, question number 2. This is not question. A minute. Right. This is the question. In this question, suppose that representative consumer is endowed with H equal to 12. So then you have to identify this particular consumer consumption level can be end with the 12 hours. That means you got only 12 hours to spend one of the particular consumption purposes. It may be consumption or
Right.
less, anything, right? This endowment is
Yeah.
very important to understand the calculation related to that particular question. Okay, and preference are represented by this is only preference. Okay, preference means the expectation for the consumption ability or consumption situation. But we know that according to the market and according to the income level, uh, consumption can be changed. But they expect to consume that kind of level. That
Yeah.
expectation can be considered as preference are here. Okay. So then in here we have to identify the difference between wage and non-wage income and nominal wage and real wage. Okay. Three type of factors are there. First one is real wage and nominal wage and non-wage income. Right. First of all, we will discuss about the nominal income. No, sorry, nominal wage. Nominal wage. You can say financial income also. It is similar to the nominal wage. Okay, financial income. As example, wage is considered as a return for the workers. Return for the workers. Actually, workers are working in any kind of organization. They are providing mentally and physically effort for the production process. Then organization try to pay for that one. That payment or that income considered as wage. Nominal wage means the financial value of the wage. Financial value. Financial value of financial value of the labor. As example, for one day, worker, daily base worker, earn 2,000 rupees. That 2,000 rupees considered as nominal wage. But in real wage mean nominal wage rate, nominal wage divided by the price index. Nominal wage divided by the price index. As example, in that person earn only 2,000 rupees for 1 day. So then he's going to only consume X commodity. The price of the X commodity is just 100 rupees. Then we are going to divide that 2,000 from 100 rupees. So it becomes 20. So 20 is the real wage. Real wage. In real wage, you can identify this real wage always represent buying ability of the person. Buying ability of the person. So according to that buying ability, they can satisfy their preference. That is why it is included in here. Actually, in that position, in this, they are considering about real wage, not nominal wage. If any question provide nominal wage rate, you have to convert that nominal wage rate into real wage by dividing the price index or price of the certain commodity. Okay. Right. At that point, you have to understand non-wage income. So as example, A, the person who namely known as A, doing a job. He earned 35,000 rupees for a month. This income considered as wage income, right? Nominal wage income. But sometimes they are doing extra business activities, or extra anything, right? So they are going to earn 15,000 rupees for that activity. For example, this person doing a job, but in evening time period, you are going to write the picnic or anything, something like that. Okay, then they can earn extra money. So that earning can consider as non-wage income, right? So why they are providing those things? They are providing those things to clarify the consumption of the consumer, certain consumer. So you already given that particular equilibrium. Already given particular equilibrium. By using that equilibrium, you have to consider about the consumption pattern of the certain consumer. How we can consider, right? Always we know that Z always equal to A plus BY. According to the macroeconomy also, we consider that consumption equal to autonomous consumption and consumption with marginal propensity to consume and a level of income. Level of income and the autonomous consumption consider, those are the factors which determine the total consumption of any consumer in macroeconomy, right? But in here, you have to identify the consumption of the certain person will be depend on both this one. First one is consumption. Before calculation, you have to derive the equations. That is why I'm going to describe that one. Okay, consumption. First of all, wage. We have to consider about wage, right? The consumption will equal to wage plus other, I mean, non-wage income.
So that's like dividends or like an inheritance?
Yeah, dividends, something like that one. Capital gain, no dividends, anything. Right?
Okay.
Non-wage, wage, non-wage income, or any extra income. So if there any kind of extra income, we have to include that one also, right? Any kind of extra income, so we have to include. In this position, we don't have any kind of extra income, so we have to consider consumption must always equal to wage and non-wage. Why? Why we think about that one? In practical level, you can't think like that one. Always income is not equal to the consumption, isn't it? In practical situation, yes, we agree with that. But in microeconomy, already before identify the consumption and IC curve, each and everything utility functions, we consider always income equal to consumption. That means this particular person is not going to save money. That is why income directly equal to the consumption. What they earn, they are going to consume it. That is what happened. That is why already consumption must be equal to wage, real wage and non-wage income in the economy. Right. So then we can create the equation for that one. Right. The consumption means C. We can put that C. Wage means real wage. Okay, then we already get that real wage in a previous question also, right? How we can earn money? Working as a worker in any kind of organization by giving labor. But it depends on that one, H minus L. L means leisure, hours. Already calculate that part in the question number 1. Plus non-wage income. So we got non-wage income as this one, isn't it? 5
yeah.
minus T. Actually, in there, 5 mean other income, T mean taxes. Okay, T mean taxes. Right. So we know that the income and disposable income is a different scenario. Income mean earning, disposable income mean income minus tax plus remittance or something like that.
Right. Okay.
It is related to the macroeconomics also here. Right. We already create the equation for that one. C equal W within brackets H mean hours. How many hours are there to work? And minus leisure plus 5 minus T. T mean taxes. Okay. Right. This is the methodology. You have to develop equation before calculate the consumption and any other things. Right. In the question number 1, after this one, question number 1, derive the budget constraint equation for all cases and draw their budget constraint. Actually, in here, you can identify 3 cases are there. In first case, W mean real wage rate is 2 and non-wage income becomes 6. But in case 2 is difference, case 3 is also different. So we have to uh, create the budget constraint. Budget constraint mean it is budget line, right? Budget line mean if you are going to consume only lesser and other consumption, so your buying ability will be represented by the budget line. Actually, this budget line will be changed if the income change, budget line change. If the price of the certain commodity change, budget line will be changed. If the non-wage income change, budget line will be changed. So those are the factors you have to identify, which shift the budget line upward or backward. This budget line already crossed the vertical axis and horizontal axis. There's no any kind of doubt about that one because this represent only buying ability of the person. Right. Let's move to the 3 type of occasions, right? T and W. First of all, we are going to case 1. Case 1 mean at that point 6 and in this point it is 2. Right? Okay. So then we have to consider that equation C equal W H minus L plus 5 minus T. Yeah. This is the equation. Right.
Yeah.
In case 1, you have to consider about W equal to 2 and leisure equal, 5 minus T equal 2. Z equal. Then after putting that value for the equations, you can calculate the value for the consumption.
Yeah.
Right? Because in here, in that table, you got only real wage and non-wage income. Then by using those things, you can calculate the CB by because of the consumption equation, right? W mean it is just 2 and 12 minus L, right? And in here, 5, we can call it 2, isn't it? Yeah, 6, sorry, yeah, 6. In this here, 2 minus 6. Oh, yeah. C equal 12 mean it is 24 minus 2L plus 6. That means 30 30 minus 2. So this is the consumption uh, of case number 1. This is the consumption of case number 1. Then you can identify if the lesser value change, what happened to the consumption. Consumption also going to be changed. If you are going to identify if the lesser increase, then what happens? Consumption has to reduce. If the lesser reduce, consumption can be increased. That the relationship between consumption and lesser is take negative value. That is why we put negative values in here. It is only for the case number 1. Did you get the idea for that one?
Yes, sir, I got it.
So then what about the case number 2 and case number 3? Did you calculate it? No.
Yes.
Can you tell me the equation for the case number 2?
Is it 54 minus 5L?
Yeah, it is 54 minus 5L. Yeah.
Yeah. And then
Case number
66
3 is
minus 5L.
C minus
66 minus
66.
5L.
Yeah, yeah. Those are the things. Okay. Now you got the values for the L. But in here, you have to identify, uh, we got 3 cases are there. But if you are going to consider about the 12 values, I mean, already created the concentration that constraint that only we got 12 hours, isn't it? Yeah, 12 hours. If you are going to put in that 12 values for the C equation number 1, I mean this one, you can put it that one. This is 12, 30 minus answer. It becomes 6. I think you can identify that one. Wait a minute. Sorry. Right. Case 1, case 1, case 2, case 3. Right. Already you got the idea. We are going to get 3 type of value for that one. I mean L. Okay. If L becomes 0, what happened to the C? C become 30, 54, and 66, isn't it? Yeah, 30. If you are going to put that L equal to 0 value to the equation, this equation, it become 30. If you're going to put the value for the this equation, it become 54. This equation 66. Right. It is L equal to 12. L equal to 12. It is sorry. Right, 66. Okay. Then we got endpoint for the leisure. Maximum you can spend only 12 hours for the certain value because h equal to 12. Okay. So then if you are going to assume that leisure values as 12, so then you are going to put that 12 value for this equation. Right, you can get plus 6. In second one, you can identify if you are going to put that 12 value, 12 multiplied by 5 becomes 60. But 54 minus answer become minus 6. Actually, consumption cannot be minus value, right? There's an error in this calculation. We have to identify consumption cannot be minus value. It is pure theoretical value in here. So we have to consider that value it as a class value. Okay. Then this also 12 multiplied by 5, 66 minus answer. It is also become 6. Right. Those are the tables and consumption and occasions we already identified. By using that one, you can draw the graph. Right. In here, you have to consider that horizontal line represent the horizontal axis represent the leisure. Okay, horizontal axis represent the leisure. Horizontal axis represent the leisure. Okay, this is L, right? This is consumption, right? In here, we are going to label it. This is C, this is L, Z, right? First of all, go to the test level, right? So in here, case number 1, you already identify that uh, when lesser becomes 0, case number 1, consumption start from the 30 value. Case 1. So if L becomes 0 for the case number 2, it starts from the 54, something like that point. This is case 2. If you are going to consider about case number 3, it starts from the 66. When L value becomes 0, it starts from the case 66. Right. In here, you have to consider about the constraint. So we already identified that we got only 12. We got only 12 hours to consider consumption. So we are going to create that constraint in here, something like that. Okay, we call it endowment line. You can't exceed that point. That is why we got endowment, right? It is just 12. Yeah, it's 12, right? Okay, we got the equations in here by using the equation number 1, C equal 30 minus 2L. Right. When L becomes 0, C value become 30. V equal 30 minus 2L. If we are going to think about L becomes 0, C must be equal to 30. Okay. In next one, we are going to assume that C equal to 0. Then what happened to the L? That means 0 equal to 30 minus 2L. So then 2L into this part, 30, L equal 30 divided by 2. It is L become 50. Isn't it? Yeah. Start from the 50, right? So first one. Actually, it's over the line of the endowment, right? Over the line of the in this position. We will call that 55. You can combine that position into this position.
Oh, so it's fine if it crosses the endowment line?
Oh, it's okay. It's okay. But we have to mention after this sketch the consumption for the leisure. I mean, the time for the leisure cannot be exceed 12 hours, right? If you are
So we
going to
can,
make,
so
yes,
so case one is invalid, right?
yes, actually it is invalid. You can't consume that point. In this area, you
Okay.
can't consume. But that those values are okay. Those
Yeah,
values are.
okay.
But in after this endowment line, values are not realistic. Actually, not realistic. You can't do that one under this circumstance, under this value. Right. Next one, it is second equation. Second equation is 54 equal. Start from the 54. And if the C becomes 0, 5L must be equal to 40. That means 54. That means 54 must be divided by 5. It become 10.8. 10.8. So we'll take that point 10.8, 10 point, something like that one. This one, 10.8. 54 from 54 to 10.8, something like that. Right. This is case number 2. Right? And on the other hand, next one, it is 66 minus 5p. So then 0 equal to 66 minus 5p. That means 66 divided by 5. It is 13 point. Yeah. It also similar. It is 13.2. Right? In here, should I that one is equalizing the values in here. Right. In here, you have to identify special features. Two type of special feature in here. If consumer consume case number 1, right? If consumer consume case number 1, uh, their consumption, something like that. But if they are going to shift to the consumption number 2, that means their income and the preference also change. But in here, you can identify something like parallel shift, isn't it? From 2 to third cases. It just look like parallel shift. The difference between in here, I mean 13.2 minus 10.8, 2.4, and 66 minus 54. Yeah, this will look like parallel shift in here. Okay, so in here you have to identify what's the meaning of that one. If you can identify the demand theory in economics, demand theory developed by using two types of activities or two types of factors. First one is substitute effect. Second one is income effect. Can you remember all those theoretical framework for that one?
Yeah.
Yeah. So in demand, it is very useful to understand the behavior of the consumer. That is why I'm going to discuss it. Okay. This demand. So we know that the theory of demand already consider the negative relationship between price and quantity demand. Negative relationship. That means if the price increase, the quantity demand going to be decreased. If the price decrease, the quantity demand of the certain commodity going to be increased. We call it negative relationship. Negative relationship. That negative relationship developed by the substitutes effects and income effect. Right? As an example, if the price of the certain commodity increase, you can identify substitute commodities become cheaper than the certain commodity. Right? If the price of the certain commodity increase, you can identify certain commodity prices are increasing and going to compare the substitute commodity prices. Substitute commodity become cheaper comparing to the certain commodity, then the quantity demand of the certain commodity reduce. So already create the negative relationship between price and quantity demand. So it considered as substitute effect. Are you okay with that one?
Yes, sir.
On the other hand, if the price of the certain commodity reduce, you can identify the certain commodity become cheaper than the substitute commodity. So then when
Right.
price decrease, their quantity demand increase. So already again negative relationship. Okay. On the other hand, I mean income effect, what happens? The price of the certain commodity is a certain level, right? Demand also. But suddenly uh, price increase, really price increase. After increasing the price, what happened to the uh, real income of the consumers? It's going to reduce because we call real income, real income equal nominal income, nominal wage divided by price index. As
Yeah.
example, price of the certain commodity 10 rupees, you are in 100 rupees, suddenly increase the price into 280. In here you can consume 10 commodities. In here you have to consider 5 commodities because of price increasement, your buying ability reduce. That is why when price increasement, buying ability reduce, then you are going to reduce the consumption. We call it income effect, right? So you can identify that income effect and substitution effect by using that budget constraint. Wait a minute, I will explain that by using simple example. Okay. Otherwise, you can't understand other things. That is why I do. The price of the apple, right? Price of the apple become $5, right? Price of the orange become $10. So those are the two prices. In this particular, consumer consume only apple and orange. Right? His earning income is $100. Right? If this person go to consume only apple, he can buy only 20 apple. Only orange, he can buy only 10 orange. So this is the consumption. This is the budget flow. Suddenly, the income of the consumer increased to 200. Then what happened? The buying ability of the person increased, isn't it?
Yeah.
Income double, 100% increase. So then what happened? If this consumer only consume apple, what happened? It can become 40 values, isn't it? Sorry, 40. If this consumer consider only consumption of orange, he can consume 20. So now you can identify budget line shift upward. Budget line shift upward because of what? Income increasement, right? So now you have to identify in IC curve, if the consumer income increase, the budget line will up, shift upward. So then what happen if the consumer income become $50? Definitely the consumption of apple become 10 and it become 5. Then what happen?
Yeah.
Income curve, budget line shift to backward. Budget line shift backward. So now you have to identify if the when prices of the certain commodity constrain constant value or unchanged, when the consumer income increase or decrease, what happened to the budget line? It shift upward or backward. You can
Right.
identify that situation in here also, isn't it?
Yeah.
Case number 2 and case number 3. That's the situation you have to identify in here. Right? So already identify that situation. So then what happened? Next one. Then what happened if the price of the apple change? What happened? How to identify that one also? So consider price of apple. Already it was 5 rupees, $5. Price of the uh, orange, it was $10. Suddenly, the price of the orange changed to $2. Reduce. This is the first budget line. This is the first budget line. Now budget line change. How budget line change? Income is 100 rupees, $100. So then price of orange is just 2. Then you can consume 50. 50
Yeah.
of orange. Same value for the apple because the price of the apple not change. Now you can identify only one part change. Other part is going to be remain constant. Now you can identify similar things in here also, isn't it? When you are going to compare the case number 1 and case number 2, then what happens? So this is was the first one, and second one is change. Definitely lesser reduce, consumption increase. That is what it happened. So then you can identify case number 1 and case number 2 represent the substitute effect in here. Case number 2 and 3 represent the income effect.
Yeah.
That's what you have to identify in here by using the basic idea related to that. I think you got it, right?
Yes, sir.
Then let's move to the next one, utility maximizing problem. Okay. Utility maximizing problem. Right. Write down his utility maximizing problem. Hint: the general information is sufficient, not necessary to show all cases. No need to worry about the 3 cases. We need to consider about the general situation. Okay? So how they can maximize their utilization by considering 2 types of consumption, which is consumption and leisure. Yeah, that is it. Because already we given that equation, this one. That means the utility of consumption and L must be equal within brackets 1 plus 3C. This is the equation because we already given that. But we have to identify they can maximize their satisfaction subject to 3 cases. Subject. What are they? First one is the budget. You can't exceed the buying ability of the person. That is why we call this budget constraint. Okay. C equal W H minus L plus what is sorry 5, isn't it? 5 minus T. Yeah, 5 minus T. This is the budget constraint. Next one you have to consider the time. The time constraint also must be there. Time also must be there because in this question they already they already say that only we got only H equal to 12, right? For the lesser you can spend only less or more 12. You can't exceed that level of 12. That is the subject of time. And third one is non-negative value. The negative value mean the consumption and also similar to the leisure also. Okay, 0 must be 0 or more than that one. This one also. Okay, actually we are not going to consume 0 value because both consumptions are must be consumed, right? So those are the consumption constraint. By using that one, you can identify the profit max. How we can identify the profit maximization level? Actually, by using the MRS, marginal rate of substitution. Actually, if you are going to consider about two types of commodity, income or budget must be equal to marginal utility of X and marginal utility of Y. That is the theory. That means if I am spending 50 rupees, marginal utility of one commodity, this we call C, marginal utility of L must be equal to the income. That is the point where we consider as uh, utility maximize. Something like that one. This budget line represent the income, but this one IC curve represent the preference of the consumer. That is what we call as marginal utility. So marginal utility cross the line of budget. That's the meaning of maximizing the utilization, right? By using real wage rate, right? Then you have to equalize this marginal utility of consumer consumption, marginal utility of labor must be equal to real wage rate. Real wage rate means W. That is the methodology you can calculate the maximum level of satisfaction for the certain commodity, right? So total utility function already given in here. How it equal L plus 3 within bracket C. So then what happen? If we can convert that uh, equation into the easy methodology, you can easily calculate. Okay, within brackets, this one you have to calculate in a simple manner. Okay, C multiplied by L. Then what happened? It become LC. 3 multiplied by 3C. Okay. So this is the equation. So that equation is here. Then you have to this is total utility equation. Total utility equation. By using that total utility equation, you can develop marginal utility equation, marginal utility of C and marginal utility of L. L. Okay. How we can derivative. Create the derivative. Okay, we are going to marginal utility of L. That means total utility divided by subject to L. This is the methodology. So then what happened to the next one? Next one means uh, marginal utility to consumption. It also similar. Marginal utility to C. Total utility function derived by C, isn't it? Yeah, C. This must be L. Okay. Then take the total utility function uh, LC plus 3C. This is total utility. This is total utility. Right. Then we are going to calculate the marginal utility. Subject to the first one is its consumption. Okay. This one. In here you can identify for the consumption only good V value only 3. Uh, this is related to the L. So then what happens? MU MUL. It is MUL. MUL. Yeah, MUL. Mean del total liquidity function derived by the subject to L. Right. That is what you can identify in here. Only C, isn't it? Only C. But
Yeah.
consider about MUC. C. Two type of things must be there. By considering that one must be L here, must be 3. I mean plus value, isn't it? Plus. Those are the L values. Sorry, marginal values. Marginal utility of L is C. Marginal utility of C is L plus 3. It is simple. So by using that one, you can calculate each and everything. Actually, you already identified that MU C divided by MUL become equal to the W. So then you can put the value for that one. MUC mean MUC. Yeah, MUC mean L plus 3. MU mean C must be equal to which? Am I correct? Who change in that one?
Yeah.
I think this is the final. No need to calculate the each and every point. Actually, you can
Yeah.
calculate that case, three cases. You got value for the L, you got value for the C.
Right.
Again, you got value for the C, and you have to consider all those values are similar to the WW mean that point wage rated. Okay, you can calculate that one. I think no need to calculate. Oh, yeah, not necessary to show the all cases, just only for the separate cases. Are you okay with that one? Okay. They are
Yes,
asking
sir.
uh, find the optimum consumption bundle for each cases and illustrate them on the graph using budget constraint curve train in equation question number 1 and indifference curve. In first the plug the value into the optimality. Yeah. Okay. Now you have to consider what question number 1 again. In that question number 1, we already create the graph related to the positions. And 3 cases are there. Right? 3 cases are there. So optimum bundle can be utilized as profit maximizing bundle. L divided by MUC equal W. So this is the profit maximizing, consumption maximizing bundle must be there. Maximizing equation, right? So we
Yeah.
already did MUL equal to C, isn't it? Yeah. MU C equal to L plus 3. Those are the 3 equals, yeah. Marginal. So then this is the equation must be there. C divided this one, this one L plus 3 must be equal to W. So we are going to simplify that equation to identify the values or consumption. C is consumption. So then C equal W in here. It is it changed. It become multiple, isn't it? Yeah, become multiple. 3. Yeah, C equal here. W in here. W multiplied by this one. Yeah, this is the methodology. You can convert that equation into simple form. You can substitute the budget constraint in here. Then you can calculate the maximum or bundle for the each cases. So this is maximum utility labels. This equation represents the maximum utility label. Then you already identified that this equation, I mean, which one? Yeah, this equation is considered about the budget constraint, right? I mean, W, I mean, C equal W H minus L plus beta, sorry, phi minus T. This is budget constraint. So this one and this one must be equal. Already this budget constraint consider or represent the buying ability of the consumer. So this one represent the expectation of consumer. Expectation mean consumption maximizing expectation of the consumer. So then if the income equal to the preference of the consumer, so then consumption will be there. So then income indicate by using this one, consumption preparation or preference consider about that one. I mean W L plus 3 must be equal to W, this one, W H minus L plus, sorry, 5 minus T. This represent the consumption, this represent the consumption ability, I mean income. Right? Then you can identify each and every points related to that one. So in here we can solve that equation. From W you are going to multiply the within brackets area WL plus W3, isn't it? Yeah. Equal. From in here also you can do same things. WH W L also will be there. That plus within brackets, what is I minus T. Again, yeah, you can simplify again this one, right? And we are trying to get, we have to try to get the value for the L. That is why we are going to simplify this one, right? L values. Yeah, you can take that L value in here. WL is there. This minus WL value, take this point, it become plus value WL. Right. In here, you can identify W3 go to this point, this level, this part, it become minus, isn't it? Yeah. 3W and plus 5 minus 3. Yeah. In here also you can simplify that one. WW 2 2WL equal. In here also you can, it's okay, WH minus 3W, yeah, plus, yeah, that is only, it is only. So if you are going to consider about lesser value, so it also can be that the combination of 2W and L is multiplied. If L becomes single value, so that means WH minus 3W plus 5 minus T must be divided by this value, isn't it? 2W is the value. Okay, this is the maximum consumption level. This represents the maximum consumption level. Okay, you can utilize that equation to understand the level by putting that cases as value in here. We got the value for the H, we got the value for the W also, and we got the value for the uh, 5 minus T also, isn't it? So then you can resolve that questions by utilizing that ASSS, isn't it? Are you okay up to this point?
Yes, I understood so far.
So after that, you have to calculate that solving the problems of next one. Compute the maximum utility level achieved for all cases. Maximum utility all cases. Utility maximizing equation already we got. What? W equal. Isn't it? Yeah. No. W L plus 3. Yes. Total utility function. H always become 12. So by using that one, I mean consumption equal W within brackets L plus 3. That is the equation. You can utilize that L equation each and every point. L equation is there. This equation. You have to utilize this equation to understand the value for the L with cases. I will calculate only one thing, okay? Then you can calculate. In case number 1, already say that wage is 2 and 5 minus T is just 6. So those are the values you have given in that question. By using this equation, I mean L WH 3W plus 5 minus T, that is 2W. Then it, yeah. That means 2, H mean 12, because only 12 hours we got. 3W
Yeah.
mean 2 plus 5 minus T becomes 6. Divided by 2 divided by 2. 2 because L value, W value is 2. By considering that whole value, you can take is as 6. That means when the real value become equal to 2 and non-wage income become 6, your leisure point, I mean leisure values become 6. That's the meaning of that one. In that case, you can identify leisure become 6. Right? Leisure become 6. So that is what you identify in here. Leisure become 6. And yeah, W and yeah, C that C. Total utility also can be calculated, isn't it? Yes, by putting that value 2 L if it is say L6 plus 3. Yeah, 80. That means total utility also can be calculated in here as C. It is just 80. For the case number 1 only. L6 and 18 of C. And similarly, you can calculate the case number 2. Just utilize this equation to understand the L value. After finding that L value, you can put that L value in here to understand the total utility value. So then you can calculate the C and L actually related to that 3 type of cases as L value when leisure time period and consumption can be calculated by using those 3 equations, right? And you have to put that value into in that uh, IC curve. You already I created that IC curve here. Yeah, this one. I will put that only one IC value. It is already calculated as L equal to 6, isn't it? L equal to 6. L equal to 6. C equal to 14. At the case 1, number 1. Okay. In here, Z, C equal to 80. Something like that. This cipher value, this point. Right, it is 80. This must be 6. So this is the consumption. So this is maximum utility. So
So for question 3, don't we have to find C star and L star?
T
C star and L star,
in
like how
which
it says in question 3.
question number 3? Suppose, sorry,
Like we have to plug in the values into the optimality condition, right?
yes, optimum condition. Find the optimum consumption bundles in each cases. That's it. Yeah, those are the optimum bundles are calculated already for the only one for the one cases. And then illustrate them the graph using budget constraint. The curves drawn in equation 1 and indigenous curve. And the first find the L star and the function of other parameters. Yeah, the function of other. Then plug the value into the optimality condition. Yeah. C star and L star. Yeah, it is related to the common sense, common budget, isn't it? Yeah, related to common because here I think it is related to the combination change in demand condition change, isn't it? In this position, we got only one thing. I don't have any idea about that one. How it happened? Is that so? Only one thing is there. If it is a case number 2, change to that position. By using that one, we are going to constrain the demand function. Or case number 3 is here. By using that one, consider about the budget line. Sorry, consumption direction also. I think it is not the case in here. I will check that one. I don't have any idea about the things. Okay. Do you have any idea about that?
For question, which question, sir?
Third one.
So if we know C is um W into H minus L plus pi minus T,
Mhm.
should we put that in the utility function? Like U equals L plus 3 into C as like W 12 H minus L plus pi minus T, like that. And then we derive it to find L and C.
Yeah. It is for the three cases, isn't it?
Yes.
Yeah. It's okay. We already calculated only one case as case number one. After calculating the case number 2 or 3, you can take the bundles for the L and C. Yes, it's okay. Question number 1, indifference curve. In question number 1, right. In question number 1 also we already did the calculations for the budget line. Three types of budget line, the three cases. Listen what asking that in the drawing equation question number 1, indifference curve. We don't have any kind of indifference curve into question number 1 because already we calculate the three type of three cases as budget line only, isn't it? Yes, only budget line. Okay, I will check that again. Okay. Okay.
Okay, so that's fine.
Okay. Okay. Question number the maximum utility. Question number 4, isn't it? Yeah. Question number 4, maximum utility. I mean, U equal to L plus 3 equation. This
Yeah.
one already given that in the question number 2, U C comma L equal to L plus 3 within bracket C. This is the maximum utilization of the consumer.
Yeah, but then we will need the values, right, from question 3? Like
Yeah,
the
we will need the value for the questions. Yeah, for the L and C. For the L and C, isn't it? For the L
yeah.
and C. I just want, yeah. In here, they didn't mention any kind of cases, isn't it? Yeah, no cases. Remember the all cases.
Yeah, I think for all because it says
All.
plug the values into the optimality condition. So I think they mean for all three.
Yeah. Then you have to calculate the all cases as L and C value, isn't it? Yeah.
Yeah.
After that, all cases as you can calculate the maximum utility level by using that equation. That is what you have to do. I will do only one cases, okay? Only for the one case. Uh, in here, you can identify for the one first case, you calculate the value for the 6, value for the L, it becomes 6, value for the C, for it become 80. Okay. Maximum level, utility maximum utility equation given as U equal L plus 3 brackets C. So you got the value for the L, it has in already 6 and see for the 6,
18, yeah.
18. So then you can put that value in here. L means 6 plus 3 multiplied by 18. So total utility become 162
Yeah,
for the first case only. Case number 1.
right. So we do the same thing for 2 and 3 then.
Same thing for the 2 and 3. Okay. Right.
Okay, yeah.
Based on the answer number 1 and 4, now imagine the consumer situation change from case 1 to case 3. Case 1 to case 3. Okay. In other words, the consumer wage increases. Oh, now you can identify why I already discussed about this one. Changing wages, shift the curve.
Yeah.
Changing prices, change the direction of the curve. Right. This case is related to that one. Right. Consumer wage increase from 2 to 5, while the rest remaining same as before. I mean 5 minus D or C, the same. In this case, you can think of the budget constraint. For case 2 is parallel shift of case. From case 3, case 2 to 3, it is parallel shift. Yes, we already identified that one. Based on information given additionally here, answer the following question. Identify the substitution effect on the graph and calculate it in terms of CN. Actually, substitution effect happened in here related to that one. I already said that. This one.
Okay.
I mean case 1 and case 2. The income
Yeah.
effect change case 3, 2 to 3. Right?
Right.
So then if you are going to calculate anything related to substitution effect, you have to calculate between case number 1 and case number 2. If you are going to calculate anything related to the income effect, you have to calculate between case number 2 and case number 3. Right?
Mm-hmm.
That is what is happening in here. First of all, we are going to calculate that, identify the substitution effect. What's the meaning of substitution effect? We are going to substitute the commodity as already taken. We are going to substitute apple to orange, and we are going to substitute orange for the apple. Okay,
Right.
it can be changed, right? So then already given another additional information related to W. W change from 2 to 5, isn't it? This case is happening in case number 1 and case number 2, isn't it? Yes, I mean substitution effect. Right. Then we can calculate the two type of things related to that case number 1 and case number 2, actual consumption values. So in actual consumption values is related to the case number 1 and case number 2. Actually, we have to calculate the case number 2 and 3 also. Otherwise, we can't calculate this one also, isn't it? Without calculation, this part, those part. This case only for the case 1. This part is the only one for the case 1. Okay. You have to consider about that one. 18 it's 18 and 6. Yeah. We already calculate the only for the case number 1. Actually, without calculating case number 2, you can't calculate that. Are you agree with me?
Yeah, we need the second one.
Yeah, we need second one and also third one also. Without that one, we can calculate we can able to calculate the income effect also, isn't it? Did you calculate it?
No, I didn't know how to calculate it. I couldn't do it.
Okay, okay. Then let's move to calculate the. This one is related to the uh, case number one. Okay, already identify the case number one. L values and C value. That is what we put in here. In here.
Wait, what do you need the calculation for? Like, do you mean the maximum utility for all cases
Yeah,
or the?
maximum utility cases. This
Oh
one.
yeah, that I calculated, but I don't know how to calculate the substitution and the income effect. Like, I don't know how to do that question.
Okay, then if you got the value for this one, I can continue that.
Okay, so you want the answer for question 4, right?
No, no, answer the question. Yeah, Mm, yeah, yeah, that one.
Yeah, so case 1 is 162, we got that.
Mhm,
Uh, case 2 is 238.05.
That much value?
This is for the maximum utility, right?
No. Okay. In the third question,
Oh,
we
third
derive.
question.
Yeah, in third question, we derive the optimum budget constraint and maximum utilization. So under that one, we already calculate the case number one. We got the value for
Oh,
the
so
case
6
number
and
one,
18. Yeah.
6 and 80, right? Because of the W equal to 2, W equal to 2 and uh, 5 minus T equal to 6. That is what happening here. For that one, you calculate value for the L and consumption. According to that particular equation, you have to calculate the value for the second cases also. How?
Yeah.
In that position, you have to change the W, isn't it? Because you already given that this one.
So I got 3.9 and 34.5 for case 2.
Yeah, that is what I'm asking.
Okay.
3.9 and 34 point.
34.5.
This is case number 2. Okay, then what happened to the
Yeah.
case number 3? L value and Z.
Yeah. 5.1 and 40.5.
No, yeah, this reasonable. Okay, you can put that value also. L for the second case, third case. Okay,
Okay.
and in the 3.9 or 34.5. 34.5 in here, 3.9. In again another, sorry, again another IZ independence must be there. Something like that. Okay, right. Don't worry about that one. You can, after your calculation 3 points, you can calculate that one. So already we
Right.
got the value for the case number 1, case number 2. Then we can calculate the substitution effect, right? Substitution effect. In that substitution effect, uh, income change. So already given income also change from 2 to 5. Right? Within that cases, we have to calculate the uh, L L2 and L1 values separate. Already got the L1 value as which one? 3.9, isn't it? 3.9. Yeah, 3.9. L1 value is 6 minus 6. Right? So then C2 values and C1 value must be there. In C1 value, you calculate as C2 value calculate as 34.5. 34.5. In C2 value, it is 80. Right. In here, you can calculate the 3.2. Yeah, minus 2.1 in here. Yeah, plus 16.5. Right. That means two positions are there. In one case, L consumption and C consumption are there. L mean leisure time period and consumption are there. They are going to shift from one case to second case. At that point, leisure time period and consumption change. Then again, after that one, uh, their consumption change. Actually, leisure time period increase, but consumption time period reduce. Right? Leisure time period increase, consumption time period reduce. So now you can identify this consumer got limited income. So then if any kind of consumer try to increase the leisure time period, then they have to sacrifice the consumption level from 34.5 to 80. The amount of the sacrifice of the consumption is 60.5. An increasement, what happened? It also become 2.5, right? So now you can identify that increasing the uh, leisure, help to reduce the consumption. That's the meaning of substitution value. That means 16.5 for the 2.1 changes. That means 16.5 divided by 2.1, it is 7.8. 7.81 is the substitution effect or substitution values. Actually, it is no need to calculate this point. This one is necessary. Up to now, up to this point, you can calculate. Do not worry about the negative values, okay? It is just changing. Right? Don't worry about the negative values. It is changing value. So that means to increasement of 2.1 leisure, they are going to sacrifice 16.5 consumption. That is the substitution ability of the consumer. Did you get that one?
Yes, sir.
Yeah. In here, you have to identify the income effect on the graph. Income effect of the graph on the graph, and calculate it in term of C. Income effect is representing between 2 case and 3 case. It is similar to that this calculation. Just identify the case number 3. I mean L3 minus L2 and C3 minus C2. L3 5.5, 5.1, L2 3.9. C3 mean 14.5, C2 mean 34.5. The values are there. 1.2. One is 41, is 6. Okay. The income effect is here. You can measure that one. 6 for 1.2. Income effect 6 for 1. That means the shift from the optimal consumption from E2 to E3 point. I mean, equilibrium point of this one. This is E1, this is E2, this is that one we didn't point out that one. Deep down. Okay. So then they are going to shift from 3 to 2 or 2 to 3 point. What happened? It is positive value. Both are positive values. If you are going to calculate anything related to the income effect or income elasticity, if it is positive value for the both, so those become normal commodities. Normal commodities. If it is negative value, you have to write down as inferior commodities.
Right.
Or
Okay.
given commodity. Inferior or given, both are negative values. Okay. Plus value for the normal commodity. If the values are in a high level, these values are not in high level. If the values are high level, you have to say that it is luxury commodities. Right? But in here, you can identify lower values are there. 6 for 1.2, 2 for 1.246. It is normal values. So then if 6 divided by 1.2, it becomes 6 divided by 1.2, it becomes 5. Okay, no need to worry about that one. It can be identified as normal commodity. It reveals that shift from the optimal point. I mean E2 to E3, it become leisure. It will increase leisure income, leisure consumption will increase, isn't it? Leisure income from 2 to 3. If you are going to consider about that one, from this one, this increasement. This one also increasement, isn't it? Yeah. After increasing the income, budget line up to shift to upward. This is 2, this is 3, isn't it? So budget line increasement always display increasement of the consumption of two commodities. That is why from 3.29 it increased to 5.2. From 34.5 to 40.5. It increased. So we can consider all those are normal commodities. With the increasement of income, consumption increase. So it becomes the situation for the normal commodities. If income increase, consumption reduce, what we call as given commodities or inferior commodities. If the income increase by 10%, income increase by 10%, consumption increase by 50%. So that's the nature for the luxury commodities. Right? That is
Right.
what we can identify it as income effect. To identify the changes in here, right? You can identify wealth also here, change from 2 to 5, something like in here you have already given the some type of hint in here, right? So you have to identify final question is identify the overall effect of graph in calculating each and graph. Overall effect mean I will describe that overall effect by using a table. Okay, effect, right? I mean, I'm going to point out that change of the lesser time period time, and change of the consumption. Right. In here, you can identify uh, in the first sessions. In the first session, you can identify from 1 to 2, from case 1 to case 2. If you are going to change case 1 from to case 2, the change is 2.1, isn't it? Yes, change is 2.1. Yes, minus 2.1. So then what about the consumption? First consumption was 18, it changed to 34.5, isn't it? Yeah, 34.5.
Yeah.
It become 16.5. Right, next one. L change. L change 1.2, isn't it? It is plus
Yes.
value. C change 6. Yeah. Third one also we consider in third position. 5.5 and 40.5, isn't it? Yeah, that position. 3.9 to 5.1. 3.9 to 5.1 is 3.9. Yeah, 0.9, isn't it? 0.9. Change what? Minus. Reduce it. From 3 to 2. 3 to 2. Okay. It changed. From 3 to 40.5 minus 30 point. 30 point. 40.5 minus 34.5 changes 6, isn't it? 6. So lesser change minus consumption change plus value. If consumption
Right.
change,
Okay.
are you okay with that?
Yeah, you got it.
Effect is substitution effect. We already identified that one. This one is income effect because it becomes normal commodity. Come also changing lesser and consumption also take plus value. That is why it is look like income change. Okay. So this is the change we already identified within this one. I think third one is not necessary because change one is there. Yeah. Yeah. So this is the overall value. If you are going to change the overall value, you have to calculate all those things, isn't it? I mean, plus value of the two, plus value of the two. Overall change because of the substitution and income, overall change in 2 minus 2.1 plus 1.2, it becomes 0. Yeah, 0.2. And this one. You can, no need to worry about that one. This total changes is there. Income effect, this one. Substitution effect, this one. This is the answer for the final one. Right? Okay. Let's move to the next one. Question number 3. Sorry. In here, we have to consider about the Koch-Douglas production function. Actually, normal uh, formula for the Douglas production function is Q. Q mean production quantity. L mean number of labors are utilized to produce goods and services. K mean capital equipment for the production. And it is equal to the A. A mean, I mean technological growth, right? And L, beta, A, alpha, right? Do you have any idea about the combination of that one? Oh, each and everything combined with the multiply. Okay? I mean, A multiplied by L multiplied by K. That's the nature, but we are not going to put the symbol in here. That beta value is related to the labors, that alpha value related to the capital. Okay. You have to identify that position in here. They are going to say that consider economy where our production function in represent firm given in here where z equal to 1. That means z represent a. Okay. A represent by z. Yeah. Equation can be changed from equation to question to question. But you have to clarify that what's the meaning. Right? Assume that firm organize the production process when the quantity of capital K equal is fixed. Okay. K is fixed. K is 9 and it is fixed. What that means? In here, you have to identify this particular organization conduct their production process under short-term period. we can divide the production time period into two categories. First one is long-term production process and short-term production process. Under short-term production process, you are unable to change the capital factor. You can only change variable factor. Variable factors mean labor. Only variable labor represent the variable factor. Capital represent the fixed factor. Fixed factor mean machineries, equipments, buildings, vehicles, something like that. But in here, L represent the variable factor. Variable factor mean labors, ingredients, something like that. Okay, you have to identify the value of the K cannot be changed under this certain time period. I mean short term period. That is why they already say that short term. Right. What they are going to think about that one. But in here you can identify as example Q equal to L 0.5, K 0.5 in here. By identify the value of beta and alpha, you can identify the returns of the entire organization. Return of the entire organization. That means L mean the number of workers. As example, if you are going to utilize 20 number of workers, they will produce 20 x 0.5. In bracket, that means the production amount is 4.4. That's the effect of 20 workers to the entire production process. If they are going to utilize 10 capital equipment for the production process, then what happened? It become 10, 0.5, 3.1622, right? By identify those value, if the beta value plus alpha value equal to 1, actually they are creating constant return to scale. Constant return. Okay. If the beta value plus alpha value is less than 1, it becomes how we can say decreasing returns. And beta value and alpha value equal to greater than 1, it provide increasing return. What the meaning of increasing return? No? So as a combination, in example, this is input, this is output, right? The particular producer try to increase their input by 20%. Increase their input 20%. As a result of increasement of 20% of input, they had to increase their output also 20%. Similar return.
Right.
That's the meaning of constant return. On the next option, they are going to increase the input by 20%. As a result of increasing 20% of input, they can increase the 40% of output. I mean, the output value take greater value than the input value. It changes. So it becomes increasing returns, right? We call it increasing return. It's a favorable time period for the consumer, producer. In next 20% increase the input. As a result of that one, they able to increase only 10% of output. It's not a favorable situation for the producer. So we call it decreasing return or diseconomic scales. Okay, right. So those are the three patterns you can identify in here. Without calculating, you can take the answer for the first answer. Does the production function have the constant returns to scale property? Can you show it mathematically or a specific example? If you calculate mathematically, you can get only answer that is constant. Right? That is constant. How you can prove that one? Take a value for the capital and labor. Okay. As example, you can say that capital inputs are 4. Inputs first of case. Labor inputs are 60 in first case. Second case, you can take uh, after utilizing capital 4 and labor 16, you can put that value into here and you can calculate the Y. Y means final production output. And you have to put that 1 for the Z. Okay, then second case, capital become double. It means 8. Labor become double. It be 32. Then by using those values, you have to put that value in here. ND mean number of demand for the labor. I mean L. Okay, do not worry about it. K mean capital. But put in that values, you can calculate the value for the definitely Y value also must be double. That it is something like that one, isn't it? In input
Right.
increase and output increase. You can calculate by using those things. Actually, it is not a calculation activity. Right? Put in that value for the equations. You can take the Y value. After one case, second case also putting that value. You can compare the Y values for the first cases and second cases also. Right, I have to wind up that session because now I have to start another 90.
Oh yeah,
Okay,
that's fine, sir. Yeah.
okay. We will discuss this one again. Okay, right?
Okay, sir. So by the
Mm.
way, I told Tata and he put the money for
Okay.
the
Didn't worry about it.
class.
Okay, and anything you can say, send me a WhatsApp message. Anything to clarify about calculation or theory.
Okay,
Okay.
sir. Thank you. All right then. Thank you, sir. Good evening. Bye-bye.
Thank you. Good night.